Hello, this is Christopher Murphy. This is my presentation for a sensitivity analysis tool for capital budgeting. One thing to note, that this link right here is currently the link for my YouTube channel itself, but not the specific video because I haven't uploaded this yet. So once this video is uploaded, I will update this slide to reflect the accurate URL. So there's essentially three different things that we're going to be looking at as far as the sensitivity analysis. We're going to be looking at the qualitative steps that are required to complete this, and then the quantitative steps. And then we're going to look at how to incorporate project risk into a sensitivity analysis. And then we'll finish with references to a few outside sources that I used to help create this. So as far as the qualitative steps for a sensitivity analysis, there's a few different things that need to come together, essentially. You need to be able to identify key variables, which, I mean, this is very broad. It could be really anything related to the study, anything that you want to run the qualitative steps on to see a potential output when you provide a specific input. So that it could be anything from a specific cost for a machine or any kind of equipment or anything like that. It could be temperatures or all kinds of stuff. It's pretty limitless there. It just depends on what you're conducting your sensitivity analysis on. And then you also need to define your parameter ranges. I use temperature ranges as an example. So like if you're, if you're designing electronic equipment, you need to be able to monitor the internal temperatures to make sure that the internal pieces are not overheating and melting themselves. So you may have a bottom line range for when the device is powered off, and then a top line where it's, the device is running at max performance and it's pumping out as much heat as it is capable of. So you could have something like that where you're monitoring these different temperatures at different times through a device's life cycle. Next is designing scenarios. And this, I would say, is kind of a two-parter, because in many cases, what you want to do is you want to have a baseline that you can use to compare your simulations to your simulation data in the next step, the next two steps, really. But essentially what you're doing is setting up use cases where, a particular variable, everything else being defined, one variable changes, and, you run a scenario to see how that affects your inputs and your outputs. That's essentially what designing scenarios is. And you want to do that for as many different variables as you think could be, could have fluctuations or just be, something that you need more information on. Performing simulations, this is where you run through the analysis to determine results and variations. So this, it combines with the previous step of designing the scenarios where at this point you're running through the simulations to essentially pull out the values for your inputs and your outputs to find variations in the data. And last is simply to just analyze the results. This includes things like logging, analyzing the data. It could be visualization if you want to use like RStudio or something like that. It's really just up to your company how they want to go about it. Some companies may not care about visualization as long as they have the data analyzed and can make use of that information. That could be enough for many companies. Okay, now on to the quantitative steps for sensitivity analysis. Well, let me start by saying that sensitivity, as you see on this first bullet here, is the percentage change in an output divided by the percentage change in an input. So, for example, if you're, you're trying to calculate a potential new profit, it would be the new profit is equal to base profit times 1 plus 10%, which gives you a base profit of 1.10. But this section in parentheses, the 1 plus 10%, is essentially the variable that's changing, the 10%. So that's how you're getting to the 1.1 in this particular example. And this requires dependent and independent variables because essentially you want to test one thing at a time. I can't think of what it's called off the top of my head. I know there's a term for it where you test one variable at a time and you provide a distinct value at the end of each of these. But unfortunately, I don't remember what it is, and I don't have my notes in front of me. So essentially you change one variable at a time, record how it changes both the input and the output, which is essentially what's happening here. You change the one variable, like let's say, there's a new tax that's going to affect your profits or something similar like that. It could be anything. You would want to run this formula essentially to find out how that affects your base profit, your new profit, and then you can develop business plans from there. So to incorporate project risk into a sensitivity analysis, I found that a lot of companies break it down into two different categories. And one company that I found, which I have a link to their website in the references, if you'd like to look at it, is they describe it as core macros and secondary macros. And essentially what this is core macros are their risk factors, like potential risks that could occur that correspond to the principal drivers of the return. Secondary macros are things like emerging markets, foreign currency, local inflation, and stuff like that. So I would say a lot of the time what you're going to be changing, your variables is going to be a singular core macro at a time, and you're going to be looking for how that affects your returns and even your input in some cases. And then as the you add the percentage change of a risk occurring, which you would take as a decimal just for simplicity's sake of doing the math. And you add that to the formula to generate a new outcome that includes the estimated percentage of risk into the new answer. So from what I understand, the way this works is, let's say there's a 60% chance of a particular risk occurring. Essentially, you would multiply the original outcome by 0.6 to generate a new value that includes the risk value at that percentage chance of it potentially occurring. And that's it. This is my references. See, Vent 2 Sigma is the company that I use to find information on how they define their categories, the core macros and secondary macros. Study, this is a paid subscription, so I'm not sure if you'll be able to access it. I think they have a preview version, so you can see some of the material, but I'm not sure how much of the material you'll be able to access without a subscription. Yeah, thank you so much for watching, and I hope I explained everything well, and yeah, goodbye.